Hello my dear students, I warmly welcome you to CR Digital Classes. In this lecture we are going to discuss problem based on the Picard's method. Okay, so see the statement first of all. Obtain Picard's second approximate solution of the initial value problem dy by dx is equal to x square by y square plus 1, comma, initial value condition is y of 0 is equal to 0. Okay, after that find y of 0.25 and y of 0.5 and y of 1.0 correct to the 3 decimal places. Okay, so this is the question. We have to derive that Picard's second approximation. Okay, second approximation solution of the initial value problem. Clearly he mentioned that second approximation, that means up to n is equal to 2 we have to take in the nth approximation formula. After finding that second approximation formula, we have to find out this values. At x you have to substitute 0.25, 0.5 and 1. For them we have to find out the corresponding values. Okay, so in the previous examination, the problem based on the Picard's method is, last we discussed in the previous lecture, that is derive the Picard's method. That question has asked in the previous examination. Okay, so out of 4 methods, definitely each and every method will come either in the form of problem or in the form of derivation. Okay, so see the solution. Picard's method. Given initial value problem is dy by dx is equal to x square by y square plus 1. Okay, so that is taken as equation number 1. And initial condition is y of 0 is equal to 0. Y of 0 is equal to 0. If you compare with y of x naught is equal to y naught, then what is that x naught value 0? Y naught value 0. After this, from the Picard's method, the nth formula, the formula for the nth approximation is given as y power n is equal to, or nth approximation is equal to y naught plus integration over x naught to x f of x comma y n minus 1 approximation dx. Okay, this is the formula for the nth approximation. Okay, now substitute the y naught value. So okay, so y nth approximation is equal to y naught value is 0. Okay, and substitute the x naught value. So 0 to x f of x comma y n minus 1 approximation dx. So therefore y nth approximation is equal to integration over 0 to x f of x comma y power n minus 1 dx. So that is the formula, final formula. So now in this formula, so we have to apply that n is equal to 1, you will get the first approximation. N is equal to 2, you will get the second approximation. In the problem they asked only up to second approximation. So now let's start for n is equal to 1. Okay, the first approximation of y is equal to integration 0 to x f of x comma y y 0. Okay, y power 0 is nothing but y naught, so into dx. So since we have y power 0 is equal to y suffix 0, okay, that initial approximation y of 0 is equal to, we can write y of y suffix 0. So therefore now y first approximation of y is equal to integration 0 to 1 x square by y square plus 1. That is the function only now, y square plus 1. Wherever you have y, just replace with y suffix 0. So therefore y power 0 whole square plus 1. So okay, therefore since y power 0 is equal to y naught, so next this value you can write as 0. Okay, why? Because y power 0 is equal to y naught. Y naught is equal to 0. So therefore x square by 0 plus 1 dx. So therefore x square dx. So therefore integration 0 to 1, 0 to x square dx value, if you apply the integration, x cube by 3, okay, with respect to lower bound and upper bound. Okay, apply that upper bound and lower bound, you will get that x cube by 3 minus 0 by 3, you will get x cube by 3 only. That is the first approximation y. Next, second approximation, n is equal to 2. In the second approximation, replace small y value with first approximation value and substitute the corresponding values. You will get that integration 0 to x square by, wherever you have small y, then replace with the first approximation value x cube by 3 whole square plus 1 dx. So therefore if you simplify that value, you will get 9x square by x power 6 plus 9 dx. Okay, so now the second approximation is equal to integration 0 to x 3 into 3x. That value you can write in this format. 9x square you can write 3 into 3x square by x cube whole square plus 3 square, x cube whole square plus 3 square to get the formula. Here we are applying integration. To get that integration formula, we are doing this function. Okay, here you have 9x square. That 9 we are writing 3 into 3 x square. Okay, 3 into 3 x square plus this x power 6 we are writing x cube whole square plus this 9 we are writing as 3 square. So that is only in the next slide we are writing. Now let x cube is equal to small t. Okay, to get simplifying the above equation number 2. So we are taking the considerations, that is x cube is equal to small t. Now differentiate with respect to t, you will get 3x square into dx by dt is equal to 1. Next 3x square into dx is equal to dt. Whenever you take the considerations, okay, then upper limit and lower limit will change. So therefore upper limit is for small x is equal to x, then t is equal to x cube. Okay, so lower limit for x is equal to 0. For x is equal to 0, then you will get t is equal to 0, cube is nothing but 0 only. So therefore for x is equal to x, then t also in place of x you can substitute that x only, again you will get x cube only. For x is equal to 0, okay, so in place of t if you substitute 0, so then you will get 0. So therefore substitute the corresponding values. Okay, so x cube equal to t. Okay, so therefore 1 by, wherever you have 3x square dx, then in the place of that value you can write simply dt, and that 3 we can write as a constant outside 3, and integration 0 to x cube 1 by x cube whole square, that means t square plus 3 square. Okay, so it is in the format of, in the sense you can also see a formula integration over 1 by x square plus a square dx. For the formula for that equation is 1 by a into tan inverse of x by a. So same apply, 1 by a square plus x square formula is there. So therefore you can write 3 into 1 by a, 1 by 3 into tan inverse of x by a, and that means t by 3 into upper limit over lower limit. So therefore tan inverse of, so you can take that value x cube by 3 minus tan inverse of 0 by 3. So therefore the second approximation, this 3 will get cancelled. Okay, so therefore tan inverse of upper bound minus tan inverse of lower bound. So therefore tan inverse of upper bound, tan inverse of x cube by 3 is the second approximation. This value will become 0. Okay, something by 0 by something 0, tan 0 will be 0 only. So therefore second approximation solution is the tan inverse of x cube by 3. Now in this second approximation solution, what we have to find out, y of 0.25. So substitute tan inverse of, wherever you have small x, substitute 0.25. Okay, 0.25 whole cube by 3, then you will get 0.05, and y of 0.5 is equal to tan inverse of 0.5 whole cube by 3 is equal to 0.042, and y of 1.0 is equal to tan inverse of 1.0 whole cube by 3 is equal to 0.33322. Okay, so in this format, by applying the Picard's method, by applying the successive approximation for the given nth formula for the Picard's method, we can find the any function value, any solution, any unique solution of the given initial value problem by using the Picard's method. Okay, so in this method we can solve any type of problem based on the Picard's method. The important equation is this one, nth approximation. So that much you need to understand, you need to remember. So this is the total explanation of this problem. In the next lecture we are coming with another interesting method. Okay, so make a perfect practice, prepare well. Until bye, thank you.